Good morning. Thermodynamics. We will continue the thermodynamics cycle. Diesel cycle. The previous video we have to see in Otto cycle. Today we are going to see the diesel cycle. Diesel cycle was invented by Rudolf Diesel in the year of 1893. He put forward an idea by which we can attain higher thermal efficiency with a high compression ratio. All diesel engine works on this cycle. Diesel is used as fuel in the cycle as it can be compressed at a higher compression ratio. It is also known as constant pressure cycle because heat is added at constant pressure. The previous one, Otto cycle, constant volume process, and also diesel cycle is also called as constant pressure cycle. It has high thermal efficiency and compression ratio 11.11 is to 1 to 12 is 1 as compared with Otto cycle. This is a figure for diesel cycle. Here it's having intake valve and fuel injector, exhaust valve, intake and compression, power stroke and exhaust. You can use a 4-cylinder. First one is intake, second one is compression, third one is we can get the power, fourth one is exhaust. 4 process. First one is isentropic compression, second one is constant pressure heat addition, third one is isentropic expansion, fourth one is a constant volume heat rejection. Diesel cycle process. The diesel cycle has 4 processes. These can each be observed in the animation above. In the PV diagram, process 1 to 2 is a suction stroke. This is when the piston first moves downward, creating a vacuum that sucks air into the combustion chamber. Process 2, compression stroke. Once the piston reaches the lowest point, it moves, the pressure is up again and compresses the air in the combustion chamber to very high pressure. The pressure is so high that it heats up the air to beyond the temperature at which diesel ignites. Process 3, power stroke. The power stroke starts with a bang, as at the end of the compression cycle, the fuel is injected into the combustion chamber via the fuel injector. The fuel ignites at its mixtures with the high temperature air inside the chamber. This called explosion forces the piston back downwards, producing one. Process 4, exhaust stroke. Finally, this is when the piston moves back up and pushes by produce the combustion, mainly carbon dioxide and heat, out of the combustion chamber. This is called exhaust stroke. After this, piston repeats process 1 on and follows the same cycle again and again. PV and TS diagram for diesel cycle. First one, process 1 to 2 is a isentropic compression. Process 2 to 3 is a constant pressure heat addition. Process 3 to 4, isentropic expansion. Again 4 to 1, constant volume heat rejection. This is a PV and TS diagram. Position of piston of diesel cycle. Diesel cycle is efficiency 1 minus 1 by R gamma minus 1 into alpha gamma minus 1 into gamma into alpha minus 1. Nth is a thermal efficiency. Alpha is the cutoff ratio V3 divided by V2. R is the compression ratio V1 divided by V2. Gamma is a specific heat Cp by Cv. This is the relation of expressed in terms of temperatures shown below. Thank you.